Hello everybody, welcome into another lesson. So today we are going to talk about finding trigonometric functions of any angles. So up to this point we've been dealing with the unit circle. If you have an angle on the unit circle, your default radius is 1. But in the real world, you're never just working with the unit circle. You can have angles between lines of various lengths, or out there in the real world, in real world applications, and we aren't given a unit circle for every single set of real world scenarios. So we have to know how to find the trig functions for any angle. Well, if you are not on the unit circle, that means your radius could be something other than 1. It may happen to be 1 or it may not be 1. But in general, to find the radius, it's a Pythagorean identity that x squared plus y squared equals r squared. So here, this is the terminal side of angle theta. It makes an angle with the x-axis. The terminal side rests at 0.724. So we can take that information and we can find the radius. Let's do that here. So this means that 7 squared plus 24 squared is equal to r squared. So r squared equals 49 plus, let's figure out what the heck 24 squared is. So let's see here. 24 to the second power is going to be 576. Which then means that r squared would be 625. And since it's a length, the radius specifically is always positive. So the radius in this case would end up being 25. That's great. We know the radius, so what are we going to do with that? Since we're in the first quadrant, this is easy. What you want to do once you found your radius is make yourself a right triangle. So go ahead here, make yourself a right triangle. Now, that 724 tells you that your x length is 7. So you have a length of 7 here for your x leg. You're up 24 units, so your y length is 24. And then we now know the radius to be 25. So everything's positive in the first quadrant. From here, it's easy. We can now find our 6 trig values. So let's go ahead and do that. So the sine of theta in this case, that would equal opposite over hypotenuse. So that's 24 over 25. Then we can do the cosine of theta. The cosine, that's adjacent over hypotenuse, so that would be 7 over 25. The tangent of theta, that's going to be opposite over adjacent, so that would be 24/7. And then let's see here. So we can now find the cosecant of theta. That equals the hypotenuse over the opposite side, so that would be 25/24. We can find the secant of theta. That equals the adjacent, that equals the hypotenuse over the adjacent, so that would be 25/7. And then we could even find the cotangent of theta, because that's simply the adjacent over the opposite, so that's going to be 7/24. So this is how your radius will impact your trig values if it's not on the unit circle. So some people get this wrong. They think they just see it, oh, x value 7. That means my cosine 7. Oh, my y value is 24. So my sine is 24. Since it's not on the unit circle, that would actually be wrong. You would end up getting that wrong. You're missing a very critical piece where you want to find your radius. That'll give you your true trig values. So if you have an angle in the first quadrant, that's actually pretty simple. Didn't realize an orange marker would do that. I'm gonna have to clean the board already, and I just cleaned it yesterday. Oh well. That's what they make board cleaner for, right? That's some deep staining orange. Alright, what do we got next? So let's see. 5, -12 is going to be in the fourth quadrant. So we are going to be at the point 5, -12. We are actually in the fourth quadrant. Well, that's indicating the angle theta, which is this whole thing right here, is angle theta. Well, it's not going to be very easy to solve for this whole massive angle. It's clearly greater than 270, definitely greater than 180, so what you're going to have to use is the reference angle. So this would really be taking the trig values of the reference angle. In the first quadrant, you just deal with the angle itself. If it's in the second, third, or fourth quadrant, you're going to be finding the trig values really of the reference angle. So we can call that angle theta prime. So that would really be theta prime we're going to be finding the angle for, which would be the same thing as theta, just that theta prime makes it so much easier to work with because it's the reference angle. Alright, so now let's go ahead and find our radius. So again, you're going to have that x squared, so that's going to be 5 squared, plus you have a y value of -12, so plus -12 squared equals r squared. So you're going to get that r squared equals 25 plus 144, which means that r squared equals 169, and your radius, no matter what quadrant you're in, is always positive. So you'll end up getting a radius of 13. So now let's go ahead and draw ourselves a right triangle here. So here is our right triangle. Now this tells us here that since this point's on the terminal side of the angle, that our x has a value of 5, so we're over 5. Our y value is 12, we're down 12, and yes, we actually do put the negative, because we're going to get some negative trig values, but our radius is 13. The radius is always positive. Now we can proceed to find the 6 trig functions. So that sine of theta prime, which really is the sine of theta, it's just simply finding the reference angle, which would be the same thing. So sine is going to be opposite over hypotenuse. That would end up being -12/13. Your cosine of theta, well, that would be your adjacent side over the hypotenuse. So that would be +5/13. The tangent of theta, that equals your opposite, or theta prime, I should say. Same thing, just reference angle. So the tangent of theta prime is opposite over adjacent, so you would end up getting -12/5. Alright, let's find the cosecant of theta prime. The cosecant is always going to be the hypotenuse over the opposite side, so you would end up getting -13/12. Then we can find the secant of theta. That's going to be the hypotenuse over the adjacent side, so that would be +13/5. And then the cotangent of theta prime is going to be equal to your adjacent over your opposite side, so that'd be negative 5/12. So there are your 6 trig function values for this particular angle. Alright, let's move on again here. I want to do 2 more of these, and then we're going to do a few exercises that just simply answer a question as opposed to working out a problem. Alright, so what's the next point? Oh good, we're going to go into the second quadrant. Very good. Alright, terminal side of the angle is located at the point negative 2410. So that's going to actually put us in the second quadrant this time. So right here is our angle theta, which means in reality we're going to find the trig values for our reference angle, which right here would be theta prime. Alright, so next thing we need to do then is find our radius. So we will take that negative 24 to the second power plus that 10 to the second power, set that equal to our r squared. So then you'll end up getting positive 576 plus 100 equals r squared. So that means that r squared equals 676. And I'm simply not sure if that's an even root or not. I would like to believe it is, but I don't rightfully know. It is. It's 26. So that means we get a radius of 26. And again, no matter what quadrant we're in, we're going to have a positive radius. So now that we know the radius, let's go ahead and draw ourselves a right triangle from the terminal point. Alright, so that x value means we have a length of negative 24 since we're in the second quadrant. And again, it's not that the length's negative, it just indicates which direction it's going. And then your y value is 10 since you go up 10. And then your radius was deemed to be positive 26. Okay. Now that we know everything, let's go ahead and find our trig values. So the sine of that theta prime is going to be equal to the opposite over the hypotenuse. Well, 1026 would reduce into 5/13. Alright, so what about the cosine of theta prime? That's the adjacent over the hypotenuse, so negative 24 over 26 would turn into negative 12/13. Alright, then we have the tangent of theta. Well, or I should say theta prime, that's the opposite over the adjacent. So that would be 10 over negative 24, which would end up being negative 5/12. Alright, let's go ahead and find the cosecant of theta prime. So that's going to be the hypotenuse over the opposite. 26 over 10 turns into 13 over 5. Let's find the secant of theta. That's going to be the hypotenuse over the adjacent. So negative 26 over 24 becomes negative 13 over 12. And then last but not least, let's find the cotangent of theta. So that, of course, is adjacent over opposite. So negative 24 over 10 would turn into negative 12 over 5. And there are your trig values for this particular angle. I'd like to do one in the third quadrant. I want to do one in each quadrant just so we get the full workout. Man, that orange marker really did a number on my board. Don't know if I'll use that one again. Anyway, so let's go to the third quadrant. Good one. The terminal side of the angle lies at the point negative 5, negative 6. So we are clearly in the third quadrant. Well, what we're going to do then is find angle theta. We're trying to find it for angle theta, but keep in mind, since we're in the third quadrant, we'll really be finding the reference angle for theta prime. It'll just make your life a lot easier. Well, the next order of business is to find your radius. So you're going to take that negative 5 to the second power plus that negative 6 raised to the second power, set that equal to r squared. Well, that's going to give you 25 plus 36 equals r squared, which means r squared equals 61. And unfortunately, 61 is not an even root, and it doesn't break down any further, so you're just going to get a radius of the square root of 61. So that one's not so nice. But now that we know our radius, we can draw ourselves a right triangle from the axis to the endpoint. Alright, so there's our right triangle. So our x value is negative 5, so the length of x is negative 5. Our y value is negative 6, so there's our y side, and then our radius is the positive square root of 61. Not a very nice one, but it's what it is. Alright, now that we got that, we can find our 6 trig values. So the sine of theta prime equals the opposite side over the hypotenuse, so that would be negative 6 over the square root of 61, which would turn into negative 6 times the square root of 61 all over 61. Now let's find the cosine of theta prime. Cosine is adjacent over hypotenuse, so you would get negative 5 over the square root of 61, which would turn this into negative 5 times the square root of 61 all over 61. Alright, so now let's find the tangent. The tangent of theta prime, that's the opposite over the adjacent, so negative 6 over negative 5 gives you positive 6/5. So the tangent's actually positive since it's in the third quadrant. Let's find the cosecant of theta prime. The cosecant is the hypotenuse over the opposite side. You would end up getting negative square root of 61 over 6. Alright, let's find the secant of theta prime. The secant is the hypotenuse over the adjacent side, so you would end up getting negative square root of 61 divided by 5. And then last but not least, let's find the cotangent of theta prime. So the cotangent is the adjacent over the opposite. Negative 5 divided by negative 6 is positive 5 over 6. So there are your 6 trig values for this particular angle. Alright, so let's see here. Definitely going to have to clean that really well when I go to clean this board after the lesson. Alright, so we need to state which quadrant that this particular angle lies in. They give you that the sine of theta, that's not what I wanted. There we go. The sine of theta is less than 0 and the cosine of theta is less than 0. Okay. So what quadrant is your sine of theta less than 0 and your cosine of theta less than 0? Both criteria. Well, the sine of theta is less than 0 or negative, in other words, when you're either in the third or fourth quadrant, right? So we know we've narrowed it down between the third and fourth quadrant. Now, the other part of this is the cosine of theta is less than 0. Which of these two is the cosine less than 0? That's going to be in your third quadrant, right? So the answer is this would fall into quadrant 3. This will be in quadrant 3. That's where the angle will be. All right. The next one they give you is that the secant of theta is greater than 0 and the cotangent of theta is less than 0. So we got to figure out which quadrant this is in based on these two criteria. Let's start where the secant of theta is greater than 0. Well, secant is simply the reciprocal of cosine, so we could really look at this and say the cosine's greater than 0. So if the cosine's greater than 0, that means it's either in quadrants 1 or 4. We've narrowed it down between quadrants 1 and 4. Now consider the other criteria, the cotangent of theta is less than 0. Well, between these two quadrants, that would only leave quadrant 4 because the cotangent's only negative and it's only positive in quadrant 1, so that would narrow this down to quadrant 4. So this is referring to a fourth quadrant angle. I got two more of these. All right. This time we're given that the cotangent of theta is greater than 0 and we also have to consider that the cosine of theta is greater than 0. So let's consider which angle this quadrant lies in. Which quadrant this angle lies in. So first start where the cotangent is greater than 0. Your cotangent's only positive in either quadrants 1 or 3. So it's going to be in either quadrant 1 or 3. Now the other criteria is the cosine of theta is greater than 0. Well, that's going to be quadrant 1. So this is referring to a first quadrant angle. That's what we would get as a first quadrant angle. All right, one more of these. You're given that the tangent of theta is greater than 0 and the cosecant of theta is less than 0. So interesting. So we have the tangent of theta is greater than 0 and the cosecant of theta is less than 0. So which quadrant does this angle lie in? Consider the first part of this, the tangent of theta is greater than 0. Which means your tangent is only positive in which quadrant? The first or the third quadrant. So now we've narrowed this down to either the first or the third quadrant. The other part is the cosecant of theta is less than 0. Well, cosecant's just reciprocal of sine, isn't it? So you could basically say your sine of theta is less than 0, and that's true in the third quadrant. So this is referring to an angle in the third quadrant. Alright, so that wasn't so bad. Let's see. Now, we're going to find the exact values of some trig functions. Considering we're already given one trig function, we have to find the other 5. And they specify which quadrant the angle's in. So to start with, they give you that the sine of theta, in this case, is equal to 3/5. And then they tell you that theta lies in Quadrant.to. So this is an angle in the second quadrant, and your sine's positive, which makes sense. Your sine is positive in the second quadrant. So that means we want to draw such an angle. If it's in the second quadrant, then we can draw some angle theta. You're going to be on an endpoint. Now, if you're only given one trig value, what you want to do is go ahead, set up your right triangle immediately. So here's your angle theta that's in the second quadrant. So again, we're going to really base this on a reference angle theta prime to make our lives easier. Now, if the sine of that theta prime is 3/5, what does that mean? So opposite 3 over hypotenuse 5. So what we don't know is our x. We do not know our x yet. So we can base this on the x squared plus y squared equals r squared formula to solve for x. But let's keep this in mind. If it's in the second quadrant, that means our x has to be negative. So we'll actually take the negative square root of whatever we get. So this is all about to turn into then x squared plus 3 squared equals 5 squared, which would give you x squared plus 9 equals 25. And then x squared equals 16. Now keep in mind, we're in the second quadrant, so we have to take the negative square root only of 16. That would give you that x equals -4. So we now have the length being -4 since we're in the second quadrant. Alright, so we already know the sine. That's 3/5. That's easy. Let's go ahead and find the cosine. That cosine of theta prime, so that's going to end up being adjacent over hypotenuse. That would be -4/5. Let's go ahead for the tangent of theta prime. So that's going to be opposite over adjacent. You would get -3/4. Alright, let's find the cosecant of theta. That's the hypotenuse over the opposite, so that would be +5/3. Let's find the secant of theta. Well, that's going to be hypotenuse over adjacent, so you would end up getting -5/4. And then we can find the cotangent of theta, which would be adjacent over opposite. You would end up getting -4/3 for your cotangent. So there are your other 5 trig functions based on the given information. I got more of these. All right. So let's see here. What do we got next? We're given that the cosine of theta equals negative 4/5, and theta lies in quadrant 3. So this time we have a third quadrant angle. So that means then we're going to be in the third quadrant here. So there's our endpoint. It's going to have some coordinate here in a second, which we'll be able to ascertain. Since you've been given the cosine, go ahead and set up your right triangle to begin with. I should probably specify it's going to be for this angle theta here in the third quadrant, which means really we'll be basing all this on a reference angle of theta prime, just to make life easier. All right. So for that theta, they tell you that the cosine is negative 4/5, so that's adjacent over hypotenuse, so negative 4/5. That hypotenuse is your radius of 5, so we still don't know. We don't know our y yet. That's what we don't know, is the y coordinate. But they do tell you that theta lies in quadrant 3. So that means your y is going to have to also be a negative value. So we can use this x squared plus y squared equals r squared formula, solve for y, and when we do that, we'll have to take the negative square root of whatever we get for y. So that means then that negative 4 squared plus y squared equals that r squared of 5 squared. So you would end up getting 16 plus y squared equals 25, which would give you that y squared equals 9. And since we're in the third quadrant, our y would have to be negative. So we take the negative square root of 9. Y is going to give you negative 3. So we now know our y value to be negative 3. All right. And we already know the cosine, so let's go ahead and find the other 5 trig values. So we have the sine of theta equals the opposite over hypotenuse. Well, the sine would end up being negative 3/5. All right, we can find the tangent next. The tangent of theta, that equals your opposite over adjacent. So negative 3 over negative 4 actually gives you positive 3/4. Find your cosecant of theta. That's your hypotenuse over opposite. So that would be 5 over negative 3. That gives you negative 5/3. Find your secant of theta. That's going to be hypotenuse over adjacent, which would end up being negative 5/4. And then you can find your cotangent of theta, which would be adjacent over opposite. Negative 4 over negative 3 gives you positive 4/3. So there are the 6 trig values based on the given information. All right. 1, 2, 3 more of these. So we have that the tangent of theta equals negative 15/8. They give us the tangent. They also tell us that the sine of theta is less than 0. Okay, so very interesting. We have a negative tangent. So when's the tangent negative? Either in the second or the fourth quadrant. It's going to be in one of these. Then they tell you that the sine of theta is less than 0. That narrows this down to the fourth quadrant. So we can say that theta lies in quadrant 4. So now we know the quadrant in which the angle lies. So let's go ahead here. It'll have some endpoints. We're going to be finding the values for this angle theta, which really we're going to work off of the reference angle theta prime. Now let's go ahead, since we know our tangent value, let's go ahead and draw a right triangle to the endpoint. Alright, so tangent of theta equals negative 15/8. So that's going to be opposite over adjacent. So you're in the fourth quadrant, so yes, that y value would be negative 15 and your x value is positive 8. So we don't know our radius this time. We do not know the radius. Well, the good news is the radius, no matter what quadrant we're in, is always positive. So all we have to do is find the positive square root. Okay. So we can take 8 squared plus that negative 15 squared, set that equal to r squared. So that gives you 64 plus 225 equals your radius squared, which means your radius squared equals 289. Square root of 289 is 17. So your radius has a length of 17. Now we can go from here, we can find all other trig values. So let's find the sine of theta. Sine of theta equals the opposite over the hypotenuse, so that would be negative 15/17. The cosine of theta equals the adjacent over hypotenuse, so that'd be positive 8/17. We already know the tangent, so let's go for the cosecant next. The cosecant of theta equals your hypotenuse over the opposite, so that'd be negative 17/15. Let's go ahead and find the secant of theta. That equals the hypotenuse over the adjacent, so that'd be positive 17/8. And then we can find the cotangent of theta. So the cotangent of theta is the adjacent over the opposite, so that'd be negative 8/15. So based on the original given information and finding the radius, these are the values of your 6 trig functions. I should have 2 more of these, and there's one set of final type of problems I'd like to do for today's lesson. All right, 2 more. So we're given that the cosecant of theta equals 4. So the cosecant of theta is 4. Then we're given that the cotangent of theta is less than 0. All right, so we're given a cosecant of theta being 4, which means we have a positive cosecant, which means the sine is also positive. in which quadrant is your sine positive? Well, it's positive in both quadrants 1 and 2. But out of these two quadrants, your cotangent is only negative in quadrant 2. So that tells you this is going to be an angle that lies in quadrant 2. So it's always good to know what quadrant you're looking for, because that'll help you determine if you need to take a positive or negative square root. Okay, so we're going to form our angle here and our triangle from it. So we're in the second quadrant. Yikes, sorry about the nails on the chalkboard. So we're working with an angle in the second quadrant. There's our theta. So really we're going to base everything then off this reference angle, which is going to be theta prime. And since you are given one of your trig values, go ahead and form your right triangle to the endpoint on the terminal side of the angle. Okay, so if the cosecant's positive 4, so that's hypotenuse over opposite, that would be 4 over 1. What we don't know is our x. We don't have a clue what our x is. But we do know this: if the angle lies in quadrant 2, the x has to be negative. So when we use this formula to solve for x, we're going to have to take the negative square root of whatever we get. So this is going to turn into x squared plus 1 squared equals 4 squared. So x squared plus 1 equals 16. That gives you that x squared equals 15. And since we're in the second quadrant, we have to take the negative square root of that. So x would equal negative of the square root of 15. So there's our x value. It has a value of negative square root of 15. All right. From here, we can find the remaining trig functions. So let's go for the sine of theta to start with. The sine of theta, so that's going to be the opposite over the hypotenuse. That'd be 1/4, positive 1/4 at that. The cosine of theta, well, that's going to be the adjacent over the hypotenuse. So you would end up getting negative square root of 15 all over 4. All right, now the tangent of theta, that's the opposite over the adjacent. So you get negative 1 over the square root of 15, or negative square root of 15 all over 15. All right, we know the sine, cosine, tangent. We even know the cosecant. So let's go right to the secant. The secant of theta, that is going to be the hypotenuse over the adjacent. So 4 over the negative square root of 15, that's going to give you negative 4 times the square root of 15 all over 15. And then last but not least, let's find the cotangent of theta. The cotangent's the adjacent over the opposite, so negative square root of 15 over 1 just leaves you with a negative square root of 15. So there are going to be your other 5 trig values based on the information that we were given and deduced and the radius we solved for. Or I should say the length of x that we solved for. One more of these and I have 4 other exercises. So this will be a good one too. Okay, so we have that the secant of theta equals negative 2. We start out with that. And then we have that, this is really good, that 0 is less than or equal to theta, which is less than pi. So this looks pretty loaded here, but that second part especially is really directing you. So the secant of theta equals -2. Well, that's just the reciprocal of the cosine being negative, so you could say your cosine's negative. In which two quadrants is your cosine negative? In quadrants 2 and 3. So it's between these two quadrants. But the second part is they tell you that 0 is less than or equal to theta, which is less than or equal to pi. Which means it's got to be less than pi, so that means it would narrow it down to the second quadrant. So we can say that theta lies in quadrant 2. Alright, so let's go ahead and draw that theta again. And yep, here's going to be your theta. So really we'll be basing this on a theta prime for a reference angle. And then since we know a trig value already, let's go ahead and draw ourselves a right triangle from the axis to the endpoint. Okay, so what do they give us? They give us that the secant of theta equals -2. Well, that means that's going to be the hypotenuse over the adjacent, right? Well, there's just one thing. The hypotenuse is actually your radius. Your radius can't be negative. It can only be positive. So this is really going to be 2 over -1. So your x length is -1. What we don't know is y. We don't know the y length. So we can solve for that with this formula, and since it's in the second quadrant, our y value should actually be positive. So we'll take the positive square root when we go to solve for y. So we can take -1 squared plus y squared, set that equal to 2 squared. So this will turn into 1 plus y squared equals 4, which means that y squared equals 3. And since we're in the second quadrant, we take the positive square root of that, so that means y would just equal the square root of 3. Well, what do you know? We actually have, this would really be a 30, 60, 90 right triangle then. So that's the square root of 3, positive. Okay. So let's go ahead. More specifically, this would actually be a 120-degree angle then with a reference angle of 60, but we're not asking for that today. That's just a little trivia tidbit. But let's go ahead then and find the 5 remaining trig values. So let's start with the sine of theta. So the sine of theta is going to end up being the opposite over the hypotenuse. So that would be the positive square root of 3 over 2. Let's find the cosine. The cosine of theta is the adjacent over hypotenuse. So that would be -1/2. That's your cosines, -1/2. Let's see, let's find the tangent. The tangent's going to be the opposite over adjacent, so that would be square root of 3 over -1, or simply negative square root of 3. Alright, and then we already know the secant. Let's go ahead and find the cosecant. The cosecant of theta is always the hypotenuse over the opposite, so 2 over the square root of 3 turns into 2 times the square root of 3 over 3. And then last but not least, let's find the cotangent of theta. That's adjacent over opposite, so -1 over the square root of 3 turns into negative of the square root of 3 all over 3. So there's your other 5 trig values. And then we just got 4 more exercises here. But they're a little bit different. So this we got to do a slight bit more work. You'll see what I mean here in just a minute. Alright, so we have the terminal side of an angle lies on a line. So the line they give us is that y equals negative x. The terminal side of the angle lies on that line located in quadrant 2. So how in the heck are we going to figure something out like that? Well, this isn't as bad as you think. It tells you quadrant 2 on this line, so that means your x has to be negative and your y positive. Well, with these you could pick any value except for x or y being 0, because you can't have a negative length. So x nor y can be 0. You cannot have a negative length, so anything other than 0. Let's pick x equals negative 1. What do you get? You end up getting the point positive 1. So we can actually then say that our angle, that the endpoint of the terminal side of the angle lies at negative 1, 1. We could have picked negative 2, 2, any of them really, okay? And in theory, yes, we should graph this line properly, but really we're just trying to figure out trig values. So we're not getting full on into graphing the whole line because we're only worried about what's in quadrant 2. So that means we'll be finding for some angle theta, all right, which we'll be basing this off of a theta prime for a reference angle. Now this time we just know the point at on the terminal side of the angle, so we need to find the radius. Good news is the radius is always positive, so this is going to be negative 1 squared plus 1 squared equals r squared. So 1 plus 1 equals r squared. R squared equals 2, so that means the radius has to be the square root of 2. So we actually ended up getting a 45, 45, 90 triangle this time in the second quadrant. But now that we know the radius, we can go ahead and draw ourselves a right triangle to the x-axis. Alright, so that point tells us then our x is over negative 1, our y is up 1, and then we have our radius being the square root of 2. So there's all the values we need. We can proceed now to finding our trig functions. So the sine of theta, well, that's always the opposite over the hypotenuse. 1 over the square root of 2 turns into the square root of 2 over 2. That's positive. Let's go for the cosine of theta. Cosine of theta is adjacent over hypotenuse, so negative 1 over the square root of 2, that becomes negative square root of 2 all over 2. Alright, let's find the tangent of theta. Tangent of theta is going to be equal to the opposite over adjacent, which would just give you negative 1. Okay, now let's find the cosecant of theta. That's the hypotenuse over the opposite, which would just give you positive square root of 2. Let's find the secant of theta, which is just going to be hypotenuse over adjacent. That would give you negative of the square root of 2. And then we could end up finding the cotangent of theta, which would end up giving you adjacent over opposite, also being negative 1. So there's how we can even use a regular line to figure out trig values. It's actually kind of cool that we can do that. Alright, I got 3 more of these. Then we're done with the lesson for the day. Holy moly. What's next? Let me get a different black marker. I really did a number on that one. Alright, so we are given that y equals 1/3 x. They tell us that this is in quadrant 3. So the angle in question is going to be in quadrant 3 on the line y equals 1/3 x. So that means both our x and y will be negative. So let's pick x equals -3. If you do that, you end up getting -1 for y. So we can pick the point -3, -1. You could really pick any point you want that's on the line, as long as you don't put in 0 for x or y. Because again, you can't have a 0 length. So let's draw this angle in the third quadrant, that -3, -1. Next thing then is, well, let's identify the angle, which is going to be this whole thing right here, that theta, which really we'll be working with theta prime, the reference angle. All right, next thing, let's solve for the radius. So let's see, so we'll end up taking then the negative of 3 squared plus the negative of 1 squared, set that equal to r squared. Well, that means that r squared equals 9 plus 1. So r squared equals 10, and the radius is always positive, so we get a radius of the square root of 10. So now that we also know the radius, we can finally draw the right triangle to the x-axis. Alright, so that point -3, 1 tells us our x length is -3, our y length is -1, then we have a radius of positive square root of 10. Now we can proceed to find the trig values. Alright, so sine of theta, good place to start. It doesn't matter where you start, I'm just picking the sine. That's the opposite over hypotenuse, so -1 over square root of 10, that would be negative square root of 10 all over 10. Let's do the cosine of theta. That's going to be adjacent over hypotenuse, so -3 over square root of 10 turns into -3 times the square root of 10 all over 10. Let's find the tangent of theta. That, of course, is opposite over adjacent. -1 divided by -3 is positive 1/3. All right, the cosecant of theta, that equals hypotenuse over opposite, so that would just give you negative square root of 10. Find the secant of theta. That's going to be hypotenuse over adjacent, so you would end up getting negative square root of 10 over 3. And then we can find the tangent, or sorry, the cotangent, excuse me. So the cotangent of theta equals adjacent over opposite. -3 over -1 gives you positive 3. So there are your 6 trig values for this particular angle formed by the line y equals 1/3 x in the third quadrant. Now I got 2 more, they're just marginally tougher, but not really. All right, so we are given that 2x minus y equals 0. It might be better just to get y by itself. We can say that this in turn is y equals 2x. Now what quadrant? This is also in the third quadrant. So y equals 2x located in quadrant 3. So that means our x and y values will both be negative. So let's put in -1 for x. You end up getting a y value of -2. So you'll get -1, -2, which will be the endpoint of the terminal side of the angle. So -1, -2, which will really be for this whole angle theta, which will work primarily then with this reference angle theta prime. Okay. Next thing we have to do again, find the radius. So we'll take our -1 to the second power plus the -2 to the second power, set that equal to our radius squared. So you get 1 plus 4 equals r squared, giving you that r squared equals 5, and your radius is always positive, so the radius will have a length of the square root of 5. Now that we know all that, we can draw the right triangle to the endpoint from the x-axis. Alright, so that -1, -2 tells you that your x value is -1, your y value is -2, then your radius was positive square root of 5. Now we can find our 6 trig values. So let's start with the sine of theta. Sine of theta always equals the opposite over the hypotenuse, so -2 over the square root of 5 would turn into -2 times the square root of 5 all over 5. Let's find the cosine of theta. That's adjacent over hypotenuse, so -1 over the square root of 5, it turns into negative square root of 5 divided by 5. Let's find the tangent of theta. Tangent of theta is opposite over adjacent. -2 divided by -1 is actually positive 2. Let's find the cosecant of theta. Cosecant is hypotenuse over opposite, which would give you negative square root of 5 over 2. The secant of theta equals the hypotenuse over adjacent, so you would just get the negative square root of 5. Then let's find the cotangent of theta. That is adjacent over opposite, so -1 over -2 is positive 1/2. So there's all your trig values based on the given information of the line and in which quadrant it lies in. And we got one more exercise, then we're done with the lesson. All right, last one. We have 4x plus 3y equals 0. So we can turn this into then 3y equals -4x, which for finally would mean that y equals -4/3 x. So it's probably best that you solve for y and get an equation you can work with. And they tell you you're in quadrant 4 this time. So theta lies in quadrant 4 at this point. So let's find a point that lies on this line in quadrant 4. So that means your x is positive, but your y is going to be negative. Well, let's pick x being 3. So x will be positive 3. That would give you a y value of -4. So we'll be at the point 3, -4 for the endpoint of the terminal side of the angle. So we'll be going for this whole angle right here in the fourth quadrant, which means we'll work actually with the reference angle theta prime. All right, so now let's find the radius. So that radius, well, that's going to be my 3 squared plus the -4 squared would equal my radius squared. So 9 plus 16 equals the radius squared, which means that my radius squared equals 25, and the radius is always positive, so that means my radius is 5. So now that we know all that information, let's draw the right triangle from the endpoint of the angle to the x-axis. Alright, so that point 3, -4 tells me that my x value is 3, my y value is -4, and then we got a radius of 5. Alright, now we can find the 6 trig values. So the sine of theta is the opposite over hypotenuse. Opposite over hypotenuse, that'd be -4/5. Cosine of theta, because I'm going to run out of room, I'll write them next to each other. Cosine is adjacent over hypotenuse. That'd be 3/5, positive 3/5. Let's find the tangent of theta. Tangent is opposite over adjacent, so that would actually be -4/3. The cosecant of theta is hypotenuse over the opposite, so you would end up getting -5/4. Alright, secant of theta is hypotenuse over adjacent. You would actually end up getting positive 5/3. And then last but not least, let's find the cotangent of theta. So that's going to be adjacent over opposite, which would end up giving you -3/4. So there are your 6 trig values of this angle based on the equation of the line you're given and in which quadrant that angle lies, which portion of the line. So that's it for this lesson. Next lesson, we're going to do some basic, very rudimentary basic solving of trig equations and also doing function operations with trigonometry. So I hope everyone has a great day. Take care.